Hi, welcome to this new video on testing principles. In this video, we will discuss about the various testing principles. Coming into the topic, I shall make it clear that this video is only for the academic purpose and not for any commercial use.
It is always significant that you have to achieve a better results while performing software testing that should not deviate from the goal. But how will you ensure that the following the right strategy of testing? For that, we need to stick with some of the basic testing principles. So here we discuss on some of the 7 common testing principles that are widely used in a software industry. Exhaustive testing is not possible. Defect cluster, pesticide paradox, testing shows a presence of defect, early testing, testing is context dependent, absence of error. So we will discuss in detail about the various principles in the upcoming video.
The first principle says exhaustive testing is not possible. Why this exhaustive testing is not possible? We will look into it. Consider we are going to test a particular functionality. That functionality can have a multiple valid and invalid combinations. So when you start checking with a valid and invalid combination, it will be very huge and it is really impossible to test it. So what do you do for it? Instead of testing all the possible combination, you will test with a particular few combinations by selecting them based on priorities or using some different techniques to test it. Consider an example of why exhaustive testing is not possible. Say you're going to test a particular website which consists of 4 web pages, and each web page has 3 menus with 2 options each, and each option has 5 fields with 2 types of input category, and each of this input has 50 possible values. Consider how many conditions are required for testing this web page. It will be so when you compute, it will be somewhere around 30,000 test cases need to be tested. So it's very practically impossible to test each and every test cases. So what you do, you select some basic or some important combinations and then you test that and you will be performing the testing process. The next principle is defect cluster. When you test a software, you can see that a very small number of modules has a major defect into it. That is what you call it as a defect cluster. A particular example of defect clustering application is a Pareto principle, which says 80-20 rule. When you see 80% of the issues or the defects comes from 20% of the modules, and the remaining 20% of the issues are because of 80% of the module. When you see an example in a software industry for a particular project, you find 80% of the work is completed by the 20% of your team members. This is often true in many cases. Why this is happening? This is mainly because of there is a huge performance gap between the top performer and the rest of them. When you look in another example of a customer using a particular software for a particular project, you can find almost 80% of the customer uses only the basic 20% of the software features, where the remaining 80% of the software features remain unused because they feel that the features are annoying to them. The next principle is pesticide paradox. This says that when you keep on executing a same test case again and again over a period of time, which will stop detecting and which will not identify the new defects. So to overcome this, what you have to do is you have to keep on reviewing the test cases that you have written, and you have to keep on updating it, and only then you can able to find more and more defects. Let us consider an example of using pesticides in the agriculture field. What the normally farmers do to kill the insects? So they identify a certain pesticide mix and they will be spraying it around the crops to ensure that the insects are being killed. What if the same pesticide mix is being used for a long time? The insects present on the crops will get resistance towards it and will have no effect on the insects. So what they have to do is they have to keep on updating the mix of pesticides that they use to kill the insect. So similarly, this is applicable for a software testing where when you keep on using the same test cases again and again over a period of time will stop identifying the new errors. So you have to keep on updating the new test cases. The next principle says that the testing shows a presence of defect. It's absolutely true. The testing talks about only the presence of defect and it does not talks about its absence. So similarly, a software testing will ensure that it shows only the presence of defect where it does not prove it is a defect free one. When you keep on testing a particular software application multiple number of times, you can ensure only the presence of error and you can never demand that it is 100% bug free. Consider an example where a particular application or a software is being identified error free and is being gone out of the testing phase. But at the production phase, this product may come out with a new error or new defect which could not be found or which have not detected in the testing phase. This may happen. The next principle of software testing is early testing. When you look into it, the software need to be tested not only at the testing phase, it need to be carried out from the initial requirement document and specifications. When you see if any bug is being found at the requirement phase can be corrected immediately so that it need not be required to pop out to the next level of development. When you see the cost involved for fixing a bug or a defect that occurred at the earliest phase of requirement will be very less when compared to solving the same bug which has happened at the development phase. Assume two scenarios. The first is identifying an incorrect requirement in the initial requirement gathering phase, and the second one is identifying a bug after a fully developed software functionality. In this case, it is cheaper to change the incorrect requirement compared to fixing the fully functional not working document, which will be more expensive. The next principle, testing is context dependent, which basically means that there are lots of softwares developed on different domains and for different purposes. That means all the software that are developed are not identical. So there are different domains of software that are developed which need to be tested differently. So when you see the testing is purely based on the context of the software. Let us consider an example of testing an application of POS system and an ATM machine system. When you look, both POS system and ATM machine has similar purpose of transactions. But the purpose of POS system at a retail stop has a completely different purpose in case of ATM machines. The next principle is absence of error fallacy. When you see, when a software is tested completely and it is found to be no defect and it is defect free, then you can say that the software has been tested and it is 99% defect free. But what if the software is tested against the wrong requirements? Even though if you get a 99% defect free software, but it is completely made against the wrong requirement, so then it becomes an unstable. So when you see the software is tested should not be built on 99% bug free, but it should also fulfill the business needs. Then only it will become a usable software, or else if it does not meet the business needs, then it will become a unstable or an unsuitable software. Let us consider an e-commerce website that is being developed and it is being currently its requirements are being tested against the shopping carts functionality, which is being wrongly interpreted and it is being tested. So when you see finding more defects in this particular case will not help the application to move forward into the next phase because the requirement is completely being wrongly interpreted. So the main thing that need to be taken is initial level the requirement need to be properly tested. Some of the reference materials that used for these lectures. Bye bye for now. See you on the next video.